off on this. My printer over here doesn't print very dark, so that's fun. What's that?
Or now. Right on
I
it.
was trying to get it closer. Okay, so on this list of questions, the first two, it says, are both questions have to do with properties of rectangles. Again, not exactly sure what that will look like, but this question says, is parallelogram CDEF a rectangle? So you're looking at the different properties it gives you to determine if it's a rectangle. With a rectangle, if your diagonals bisect each other and are congruent, then it is a rectangle. So this is a rectangle because the diagonals bisect each other and are congruent. So is it a rectangle? Yes. And then the next one is parallelogram PQRS a square. With a square, it looks like a square. A square specifically has all 90-degree angles, and these angles would also be 90 degrees. And this is showing 86 degrees. So because of that, not a square. Also, your diagonals aren't the same length, which in a square they would be. And then for the next one, there's more instructions to this that were cut out, but it's saying that this is a rectangle and it wants you to solve for x. So this is a rectangle, and so is this one when we get to it. And to solve for x in a rectangle, the opposite sides are equal. So we can put 9x minus 58 equal to 5 feet to solve for x. So 9x minus 58 equals 5. Then add 58. X equals 7. For the next example, it talks about the lengths of the diagonals. It says QS, so you identify what QS is this whole segment right here is 62. So that whole thing is 62. And then it says that OQ, so this part right here is 10x minus 89, which because it's a rectangle, the diagonals bisect each other, so this length is the same length as this. And so 2 of these would equal 62. So I'm going to write this out up here. 10x minus 89 plus 10x minus 89 equals 62. Then to solve it, combine like terms. We get 20x minus 89 plus 89, 178. Add 178 to both sides. And just like with every other practice test, just write what I write, and then at the end I'll go around and give you credit. X equals 12. Next, move over here. Okay, HEFG is a rectangle. Find all the angle measures. So if this is a rectangle, then these bisect each other. These are all the same length. Why is that important in terms of angle measures? Well, that means that these are isosceles triangles. So this angle measure is the same as this. So this would be 31 degrees here. And then over here, this triangle is congruent to this one. So this would be 31 degrees as well, and 31 degrees over here. Then you could use this triangle here to find this angle. So 180 minus 31 minus 31 comes out to 118 degrees. And vertical angles are equal, so this is 118 degrees as well. Then what else? Then for the other triangles, there's different ways you could figure this out, but one way that I want to point out is because it's a rectangle, these are 90-degree angles here. So we can do 90 minus 31 to find this angle. So 90 minus 31 is 59 degrees. So this here, 59 degrees, and then this would be the same. Again, isosceles triangles. And then this would be the same, and so would this. Then for these two angles, there's different ways that you could find this, but one way would be 180 minus 118 since it forms a linear pair. 180 minus 118 comes out to 62 degrees. Okay. The next one, it says that ABCD is a rhombus. Find all the angle measures and segment lengths. For a rhombus, all the sides are the same measure. So if this is 9, then all the sides are going to be 9. Then as far as angle measures go, with a rhombus, the diagonals make 90-degree angles. So these are all 90 degrees. And then I put this on Alex recently a couple of times with the angles here. So the diagonals bisect the angles in a rhombus. So if this is 44, then this is 44. And then on the other side, it's the same two angle measures. And then for the last two angle measures here, I'm just going to use the triangle here, 180 minus 90 minus 44. And that comes out to 46. So then this would be 46 degrees. And again, this would be the same because the diagonals bisect the angle. And then on the opposite side, same thing. Next one. Next one says we have an isosceles trapezoid with a mid-segment. Isosceles trapezoid means that this side is the same length as this side, and then the mid-segment hits at the midpoint of both of those sides, and then this is the average of the two bases. So to find the length of the mid-segment, it's base 1 plus base 2 divided by 2, and that gives you the mid-segment, mid-S. So 5x plus 18 divided by 2 equals 7x. So to solve for x, first multiply both sides by 2. Then I get 5x plus 18 equals 14x. Then for y has to do with the angles. In a trapezoid, well, especially isosceles, like the base angles are equal, this equals this, and then this angle equals this one. And then also the consecutive angles are supplementary. So to find this angle, which would be equal to this one, I can do 180 minus 64 to find this angle, 116 degrees. So this is 116 degrees, which is equal to this one. So that's how I'm going to find y. So 116, my hand's going to be kind of in the way, sorry. 116 equals 5y plus 1. And then solve for y. $23. Next one down here, types of trapezoids. On this guide it says identify the type of trapezoid when given a diagram. I'm not sure what the diagram would look like, but here's the 3 types of trapezoids that you could have. So isosceles trapezoid means that 2 sides are the same. So 2 sides are congruent, like these 2 sides. And with an isosceles trapezoid, your base angles would be equal. So this would equal this, and this would equal this. And then the next type of trapezoid would be a right trapezoid, and that has to do with the angles. So you have a 90-degree angle here and here. That would be a right trapezoid. And then the last type is scalene trapezoid, where all sides are different lengths. All sides different lengths. But what makes it a trapezoid is it has one set of parallel sides, so this would be parallel to this, and so on. Okay, next one. For this question, it says you will have to graph, I believe, let's see, where does it say? Identify a type of parallelogram when given coordinates of the vertices. So I tried to get a sample. This one's already graphed, but you may have to graph it. Is WXYZ a rhombus? Justify your answer. Well, what makes it a rhombus would be like all the sides are the same measure, like this. And also opposite sides are parallel, so this would be parallel to this. This is parallel to this over here because it's a parallelogram. So is it a rhombus? Yes, all the sides are congruent. Okay, then next page. Okay, now we're going to talk about similar shapes. In terms of this, it says identify a similar triangle given a triangle. Find the value of a variable when given similar triangles. Identify when triangles are similar and not similar when given multiple triangles. So that's what these examples are. So the first one says, are these triangles similar here? So when we did this, what we did is we identified corresponding parts. So this corresponds with this. This side corresponds with this. And then this side corresponds with this side. And then we set up ratios to see if those ratios were equal. So I'm going to put yellow over yellow, 24 over 30 equals pink over pink, and blue over blue. Then what I'm going to do to see if these ratios are equal, the easiest way is to plug it in a calculator and see if it comes out to the same decimal. So 24 divided by 30, 20 divided by 25, and 36 divided by 45 all come out to 0.8. So yes, they are proportional, and yes, you have side, side, side similarity. Okay. What's that? What did I plugged it in a calculator, got 0.8, 0.8, and 0.8, so therefore they are the same. Okay, the next one, I'm actually going to move down here. It says solve for n. I realize the copy here is horrible. Okay, n's right here. And then the numbers that I can see right here, this is 2.5 and this is 5.5. And that one, I can't even see it well enough to write it out. But for this one, we're going to be finding the value of n. This corresponds with this side. And then this here corresponds with this side. And we're going to set up a ratio and solve for n. So I'm going to do pink over pink equals yellow over yellow. Then to solve this, cross multiply, 5.5n equals 41.25, and then divide both sides by 5.5, and we get n equals 7.5 as the answer. And then where we're going to go from here is up to this one. Again, similar triangles, I thought they might try to challenge you a little bit more where they put one triangle inside the other triangle. If they do this, then the best way to identify like corresponding parts is just to draw them separately. So there's a little triangle in here and then the larger triangle. So the little one is 2 by 3 here, and then the larger one, 11 here, and then this whole segment here would be 3 plus x. And this corresponds with this, and this side corresponds with this side. So I'm going to do yellow over yellow, 3 over 3 plus x equals pink over pink. And then use cross multiplication to solve. 33 equals 2 times 3 plus x. You having trouble with this? Okay. Oh, got it. Okay. Next. This one, which triangles are similar to triangle ABC? This one's based on angles. For them to be similar, they would have to have the same angle measures. So I'm going to start by just finding the third angle here, which is 180 minus 39 minus 37, which is 104 degrees. Then in the answer choices, I'm looking for matching angles, and there actually are none. Like, all three should be matching, and that is not happening. So not this one, not this one. It actually happens to be neither. Okay. Then down here, again, hard to see, it says ABC prime is a dilation of triangle ABC. What is the scale factor? Hard to see. There's a triangle here. And then there's also a little triangle right here. And this is your A prime, B prime, C prime. And so for scale factor, it is new over the original. And the new one is like your A prime, and your original would be your A, your original. So what we were looking for is just like a corresponding side where we can count the units. So the units of this compared to the units of this. So this is 1 unit, and then here we have 1, 2, 3, 4, 5 units. So our scale factor is 1/5. This is 1/5 the size of the original. Okay. Next one also has to do with dilation. It says FGH, which again hard to see. Here's FGH. Is dilated by a scale factor 2 centered at the origin. So the center of dilation is right here. So like this length to each of these points should double in that direction. So like if you wanted to measure it out, you could to get the new points. You just like double this length in that direction and you'd get the new points. The other way to do it is to take your original coordinates f, g, h, which f is at -4, 4, g is at 1, 4, and h is at -3, -5. So these are coordinates right here. And then you can multiply those by 2 to get the coordinates after the dilation. So f prime, g prime, h prime, multiply these by 2, -8, 8, 2, 8, -6, -10. What's that? Should I zoom in more? So -8, 8, 2, 8, and -6, -10 right here. Here's the dilated shape. So again, this shape is 2 times the size of the original. Also, these points are 2 times the distance from the origin, the center of dilation. Okay, last page. Okay, this one takes up a lot of space. Let me zoom out again. Okay, hard to see again. There is a trapezoid right here. This is figure A, and then this is figure B. Answer the questions about figure A and B below. Which sequence of transformations will map figure A onto B exactly? Choose all that apply. So you're going to go through each answer choice and determine which one will like map it right onto figure B. So the first one, looking at it, it says translate figure A 5 units up 5 units, then dilate it. If I was to translate this up and then dilate it, it would not map right onto this shape. So no to that. Then the next one, reflect figure A over the y-axis. That would put it over here. Then dilate it. Nope, not on that shape. Then the next one, rotate figure A clockwise 180 degrees and then dilate it a scale factor of 2. So if I was to rotate this 180 and then dilate it by a scale factor of 2, yeah, it would land there. And especially since my dimensions are like 2 times as big, yeah, that is accurate. This one. And then I will check this because it is a select all. Dilate figure A with scale factor 2. So let's say I dilated this first before anything. Okay, dilate it by scale factor of 2. And then rotate 180. Would that land there? It sure would. Yes. Are these similar? Yes. If you can dilate it and it ends up being the same exact dimensions, then yes, they're similar. Okay, last ones are all about trigonometry, which we're pretty good at. Let's see, the first one says find tan of B, the circle. So here is the little B thing right there. Using SOHCAHTOA, tan is opposite over adjacent. So from this, opposite and adjacent. So tan of B is 8 over 15. That's all they want. If they want the angle, which I don't think they'll keep it this easy on you. I think they're going to have a little bit more challenge to that. If they want the angle, then you just do second tan in the calculator, 18 over 15. So like in the calculator, you would do 18 divided by 15, and then, oh, sorry, it's 8. 8 divided by, I wrote the wrong number, hold on, 8. 8 divided by 15, and then second tan, and you would get the angle. So if they wanted the degree measure of the angle, let's see, angle B is 28 degrees, if they needed that. Okay, this one wants you to find the length of AC. So from the designated angle, we have hypotenuse and adjacent. So SOHCAHTOA means that with adjacent and hypotenuse, we use cosine. Cosine is 65, adjacent over hypotenuse. Multiply this by 7 and this by 7. Then in the calculator, 65 cosine times 7 is 2.96. Okay. From this one, we're going to move down here because it's almost the same concept. Angle here, opposite hypotenuse. So we're going to use sine. Sine of 20 is opposite over hypotenuse. Then for this one, the x is a denominator, so it takes an extra step. Divide by sine of 20, divide by sine of 20, x equals 3 divided by 20 sine equals 8.8. Okay, two left. This one's been on Alex. On my guide, it says identify correct trig ratios when given a right triangle. So that would be an example of this. It's all cosine y, tan of y, sine of y. This is our designated angle. So from y, we have opposite, adjacent, hypotenuse. Using SOHCAHTOA. Cosine is adjacent over hypotenuse, so 3 over 5. Tan would be 4 over 3. And sine 4 over 5. And the last example here, this is the one that was a bit challenging on the math game that we played. So the instructions for this one say find sine of theta where theta is the angle shown. So for sine, you need opposite and hypotenuse. However, they didn't give you the opposite side. So what we have to do is use Pythagorean theorem to solve for that. So it'd be 7 squared plus b squared equals 25 squared to solve for this leg. So 49 plus b squared equals 25 squared is 625. And the square root of 576 is 24. So this is 24. And then so sine of theta is 24 over 25. And that's the answer they're looking for. And that is all. Okay, so we still have 11 minutes left in class. Leave this out so I can go around and give you credit on it. We don't have the laptop, so you can get your phone.